In question 6, we have to answer a few questions about the hyperbola. We get given an equation, f of x equals x minus d over x minus p, and they tell us that d and p are constants. And they tell us this is a hyperbola, just in case you don't recognize the formula. They also give us a sketch of the hyperbola, an asymptote here at -1, and an asymptote here. Although they don't tell us what this value is, they just tell us capital P here, so not the same as that one, is the point of intersection of the asymptotes. And they give us a sketch of the hyperbola itself, with this point B of 2 and 0 given. And here's the other half of the hyperbola. That's the information we have, and we know that this graph is called f. Now question 6.1.1 asks the question to determine the values of d and p, so we have to find d and p. Now p is pretty easy. If we look at that formula, we know from a hyperbola that x minus p, this value here, determines the vertical asymptote. So if it was in the general equation, if we had f of x equals a over x minus p, whatever this value here is, if it was x minus 1, or x, let's say if it was x minus 5, the whole graph would shift 5 units to the right. Now we've seen this whole graph has shifted 1 unit to the left, so it will have to be x plus 1 there. So therefore we know that plus 1 must equal that value of negative p. Therefore p equals -1. There's your one answer. And to find d, we can just substitute this point in, b, 2 and 0. So we have to start with that y is equal to x minus d over x minus p. Now we can substitute this point in, even if we didn't have p yet. We can say 0 equals 2 minus d over 2 minus p. Multiply both sides by the denominator of 2 minus p. 0 times 2 minus p remains 0, and that top part just becomes 2 minus d. And therefore d equals 2. There you go, that's your p and d. 6.1 is answered. 6.1.2, the question states that show that f can be rewritten as y equals -3 over x plus 1 plus 1. Okay, initial equation we had was y equals x minus d over x minus p. We know that p equals -1 and d equals 2. So this would translate as y being equal to x plus 2 over x plus 1. I mean x minus, apologies, y equals x minus 2 over x plus 1. That's what we have from calculating d and p. Now we need to get this to look like that equation at the top there. So x minus 2, and we need to get it to look like that. Okay, well, we can, to get 1, we know that x plus 1 divided by x plus 1 is 1. So if we can split this up into x plus 1 minus something else, then we can get that right. So let's start by saying that y equals x plus 1. How do you get from plus 1 to minus 2? Subtract 3. And then the denominator stays the same, because the numerator here is now the same as that numerator. Now what we can do is we can split this up into two different fractions, and of y equals x plus 1 over x plus 1 minus 3 over x plus 1. We know that's equal to 1, so y equals this part -3 over x plus 1, and we know that's equal to 1 plus 1. So there you go, this is equal to the question that they ask you in the start. You could also do this with long division of polynomials, which I'll do another video on. And for now, that's the easiest way to answer that question. 6.1.3. Write down the coordinates of P, at capital P. That's that one. We need to find that coordinate. And we can see that's the point of intersection of the two asymptotes. Okay. We know the vertical asymptote has a point of -1. What would the horizontal asymptote be? Well, that's an interesting question. Okay, let's have a look. Okay, so P is the coordinate of the intersection of asymptotes. So P has coordinates x and y, and we know so far that the x coordinate is -1. So this is, let me just redraw that one. Asymptote here at -1, and another one here, which we don't know yet. But we know that this point is P, and that's what we're trying to solve. So we know it's -1 and y so far. Okay, so how will we find the other asymptote? Well, we know from the general equation of a hyperbola. We know that this tells you something about the vertical asymptote, and this tells you the horizontal asymptote. We've calculated in the previous question that the equation is equal to -3 over x plus 1 plus 1. So -1 here gives you your x value, and +1 your y value. So P is -1 and 1. There you go. Question 6.1.4. Write down the coordinates of the image of B. 6.1.4. The coordinates of the image of B. If B is reflected about the axis of symmetry, y equals x plus 2. Initial B is 2 and 0. We need to reflect it across y equals x plus 2. This is very easy. So with that rule, we know that from x and y, we're going to an image which is now x, would now become, let's just rewrite this equation. So we have x equals y minus 2. So our x would be y minus 2, and our y would be x plus 2. Okay, so initially we had 2 and 0, and now we're going to have, instead of x, we have y minus 2. So 0 minus 2, -2, and instead of y, we have x plus 2, so 2 plus 2, which is 4. So that is your image of B under that reflection. So the easiest way to do this, you have y equals something, you just rewrite that equation as x equals something, and then you have your initial x becomes that, your initial y becomes that new y. That's it for a reflection. 6.2, final question in this section. The exponential function g of x equals p times 2 to the power x plus q has a horizontal asymptote. So horizontal asymptote at y equals 1. And where is that question? And passes through the point 0, -2. So there's one point that we have on this. Now they say find P and Q. Okay. For an exponential function, we know that this Q value here is the horizontal asymptote. So since we know that y equals 1 is the horizontal asymptote, we know that Q is +1. So immediately we can write y equals p times 2 to the power x plus 1. Now we only have one unknown, the p. So all we need to do is we need one equation to solve this. We have one equation, So we can substitute that point in. Let's do that. Substituting in gives us negative 2 equals p times 2 to the power 2 to the power 0, which is the x, plus 1. Just bring the 1 across there. Negative 2 minus 1 equals p times 2 to the power 0 is 1. So that just remains p. So negative 3 equals p. That's p, and we know our q is our horizontal asymptote, so that's 1. There you go. That's it for question 6.